In this video, we're going to discuss several whole number multiplication algorithms. And the first one is a concrete. There's a couple that are more concrete, the other more abstract. The first one, it uses base 10 blocks. And base 10 blocks are a great concrete introduction to multiplication for students. So the first step is understanding that a multiplication problem, for example 24 times 23, is actually can be not simplified but rewritten with the distributive law. So that 24, let me get my pen going here, there you go. 24 is 20, or we got 20 plus 4 times 20 plus 3. So 24 times 23 is 20 plus 4 times 20 plus 3. So what I do is I represent each of those numbers along the sides of a table. So I've got 23 on the left-hand side. So here's our 23 down there. 24 on the top. And then what you do is you start sort of multiplying, if you will. You're saying it makes sense. It's a multiplication algorithm. So if you say, let's start with the ones. We've got 3 ones on the left-hand side, 4 ones on the top. So I've got 3 sets of 4. So that's why you fill in essentially the 3 lines of 4 digits, of 4 units. And on this algorithm, which is called the intermediate algorithm, that would be 12. So 3 times 4 is 12. Next, I look at the 3 times. So the 3 units times 2 tens, which would be 3 times 2 in the intermediate algorithm. 3 units times 2 tens is essentially 3 sets of 2 tens, or 6 tens. In the intermediate algorithm, over here on the right, that would be 3 times 2, which is 20. 3 times 20 is 60. Then we're going to move to the the 2s, which is actually 20 times 24. So I've got 20 over here on the left-hand side. 20 times the 4 units gives me 4 sets of longs, which would be 4 tens, and 4 tens is 8 tens. On the intermediate algorithm on the right, I said 20 times 4 is 80. And lastly, I've got 20 times a 20, and 20s and 20s create flats. 20s, so 20 times 20, or 2 longs and 2 longs, would create 4 flats. 20 times 20 is 400 in my intermediate algorithm. All right, so now what I've done is I filled in my base 10 chart. Now again, what I would do with students is you wouldn't necessarily follow along with the algorithm right away. You would just get used to having them distribute and exchange these blocks. Okay, notice that you are doing some exchanges. For example, when we said that 3 times 4 is 12, well that is, let me just get these here, that is 10 blocks, which I can exchange for 1 long, or 1 10, and 2 1s. That's what this 12 means. Again, the 12 is the 4 times 3. Okay, now what I can do is I've got 6 longs, okay, from the 3 times 10. I've got 8 longs. I could exchange those as well. Again, just looking at the concrete objects. I've got these 8 and 2 of these down here, so I take 2 of these, all 8 of these, and I would exchange that for 1 flat. So just looking at the base 10 blocks, after I do all of my exchanges, what I have is I've got 5 flats. I've got, remember, after my exchanges, 1, 2, 3, 4, 5, and I've got 5 longs, and after my exchanges, I've got 2 1s. So via just base 10 blocks, it would be 552. Via this intermediate algorithm, where you keep track of place values, really. 3 times 4 is 12. 3 times 20 is 60. 20 times 4 is 80. 20 times 20 is 400. And now I add my results. 2 and 0 and 0 and 0 gives me 2. 1 and 6 is 7, and 8 is 15. So that's 5. Carry the 1. 1 and 4 makes 5. So it's still 552. So that's using base 10 blocks to perform multiplication problems. The second algorithm. Again, we've really presented two. We presented the intermediate algorithm, which is this over here, intermediate algorithm, which is where you actually keep track of each multiplication, and the base 10 block representation. But you can simplify. Base 10 blocks get kind of cumbersome, especially when you get up to higher digits. So you can actually simplify this with an area model. Again, it's with a distributive law. You can say that 24, for example, is 20 plus 4. 23 is 20 plus 3. So you don't necessarily need to draw the base 10 blocks. But this also is very nice for following along with an intermediate algorithm. Then what you do is you multiply its area. You're finding area of these rectangles or squares if they were. So 3 times 4 gives me 12. So that's 3 times 4 is 12. I'm just following along with my intermediate algorithm here. 3 times 20 is 60. 20 times 4 is 80. So 60, 80, and 20 times 20 makes 400. You're finding the area of this figure. So we're going to add these up. We've got 2, so 12. Then we have 1 and 6 is 7, and 8 is 15 still. Carry the 1, that gives me 5. So using the area model, you find the area of each region, and this makes it sort of easier to follow along with the intermediate algorithm. Okay, so again, this is the intermediate algorithm where you keep track of each place value multiplication. Okay, finally, and this is where so it's a long process to get students to the point where they're understanding the multiplication algorithm. What we said is, let's just look at the intermediate algorithm. We said that the 12 is the 3 times 4. Okay. 60 is 3 times 20. The 80 is the 20 times 4. And the 400 is 20 times 20. That's the intermediate algorithm, which we said was 552. When you actually finally transition to the standard algorithm over here, all you do is you collapse these values. You say, okay, 3 times 4, that is 2 1s, and I'm going to write that 110 above the 2. So sort of keep track. I've got 2 1s and 110. And then you say 3 times 2, that is 6. Which actually is 60 because it's 3 times 20, but 3 times 2 is 6. Plus 1 makes 7. So on your standard algorithm, that first line basically collapses these first two lines of the intermediate algorithm. Then you say, okay, 20 times 4. Why do we shift over columns? Many students don't understand that. Because it's not 2 times 4, it's not 8, it's 20 times 4. So you say, well, that's 80, but I don't need to write this 0 right there. So I'm just going to say 8, knowing that there's a 0 right here. Okay? Now, so that is 8. There's nothing to carry. 2 times 2 is 4. Now remember, that's 20 times 20, which is 400. Okay, so 20 times 20, so you would say that is 4 in the hundreds column. So that's how that second line of the standard algorithm collapses these two lines of the intermediate algorithm. like the standard algorithm, we then add these together. 2 plus our invisible 0 gives me 2. 7 plus 8 is 5. 15, carry 1 100, so 15 tens is 5 tens and 1 100. 1 and 4 makes 5. And that is the transition from concrete base 10 blocks to a little more abstract area model, carrying, sort of following the work with the intermediate algorithm, and ending up eventually at the standard algorithm.